Hello everyone, I'm Jeff Dewar. I am sitting here with Viktoria Rojkova, who is the Vice President of Artificial Intelligence, Machine Learning, and Data Science for MasterControl. Welcome, Vika. Let's start with the basic question. What is AI? And I think you said before you can give me the easy answer or the hard answer. Let's start with the easy.
Well, easy answer that is going very well with execs and anybody who's making a decision is that it's a process of large quantities of data driving a high quality and actually lowering the cost. Right? It resonates with everybody who's making the decision. Hard answer is mainly it's a mathematical process of finding patterns in a data, just like human does.
Okay.
Right? And more examples of these patterns you have, more and more accurate your predictions can be. And we give an example of how you can predict if somebody will be late in training, right? As a human, you will do it by looking at the past history of how a person is procrastinating, how many delayed and overdue notices and tasks he or she had already. Based on that, you're kind of going to be making this decision and a prediction. So machine can do it way faster, right? And if you give this kind of pattern and example, machine can pick it up very quickly and scale it. Mm-hmm. So it can do it for 4 million tasks, for 4 million trainees. It can do it at the very, very paced kind of cadence every 24 hours. So machine learning is an enabler that has a mathematical foundation. Supposed to make your life easier.
So is machine learning sort of a subcomponent or a part of the larger umbrella of AI?
I don't want to get ourselves into this definition. There are different camps,
okay.
Right? But overall, yeah, there is a huge overlap between machine learning and artificial intelligence. And artificial intelligence is aiming for something broader. It's not just patterns that you learn. It's actually an ability to generalize to new patterns. Mm-hmm. Again, just like human will do, right? You can make a transition from a certain shape that you learn. That ellipse is a derivation of an oval. Mm-hmm. Right? Or that the rectangle is probably a broader case of a square. And machine right now with artificial intelligence are able to make that step. But that's about it. Luckily, that's about it.
On the big eventual curve, we're just right at the very beginning. Mm-hmm. Okay. All right. Let's talk about that training thing. Earlier today you were talking about using AI to help make predictions of people who will be training avoiders or training procrastinators. So what would that look like in a practical way for a manager who's working with a QMS and can use the power of AI to help manage the training process more efficiently?
Yeah, I can pull out as a manager, right? I can pull out like, let's see what's today. A guy is doing very well. B guy is like, about like 3 tasks that are already going to be overdue, and I'm not going to be waiting until they'll be overdue. I'll ping them today. A soft reminder. Third, X person is okay-ish, and then if I want to see overall my landscape of training, I can pull out all of them, and somebody who's going to be overseeing my manager's job will be seeing that how many supervisees I have who are going to be late. So it kind of creates this chain effect of how much I'm ready when a compliance comes to say that my training landscape is actually good. I'm compliant. While somebody else will be saying, oh, I have holes here. And you can actually look through some time range and see the deviations over time, see maybe there are trends, maybe there's some seasonality, There are things which are absolutely human, and somebody is having a huge and bigger load than they expected, and it is seasonal, that's why they're later. All of that is enabling a lot to proactively plan.
So would the QMS then say there is here are the people, the 22 people in this particular unit of the organization who have a 80% chance or greater of missing their training deadline certification. Something like that.
Something like that. And then it could be per specific training task,
Okay.
per specific category, per specific department. So you have all overall an ability to see how this training delay is overall spread across the organization.
And it wouldn't necessarily be, 48 hours before the training deadline is there. It could be 3 months before the training deadline is
Well,
due.
we try to be reasonable, right? 3 months delay, how actionable it is. I mean, in 3 months, a lot of things can change. So we a little bit experimented. 7 days is
Okay.
a reasonable time for somebody to act on.
Okay.
Right? Not to be too testy, not to be too kind of relaxed.
Okay, but not 24 hours
Yeah,
where you
not
don't
24 hours.
really have
24
time.
hours, there is not that much you can change.
Right, okay. And let's go back to definitions again. So machine learning, that's in your title. What is machine learning?
Machine is learning. Machine is learning the pattern with human guidance. And patterns are fed in order to predict something, right? Because you're learning that somebody is usually delayed every other second week, right? It's a pattern, another pattern. On average, person is completing the task within 27 days. It's a pattern. And then there are plenty of patterns. Taken together, those patterns are enabling the predictions because it's like conditional probability. I don't want to shower with the terms, but you're saying like, oh, there is a sun, it's 12, it's Tuesday, April 27 or something like that. According to your pattern matcher, the chances of rain are very low, right?
Okay.
So it's along those lines. Given that you are, on average, completing in 27 days, and today is 26th, and you were late with at least like 3 tasks from all your 7 tasks that you had, but last month was all fine. Like you have probably 50% of chance of being late. However, if it's a 27 day and you have like 7 out of 7 being already late, it's a very high chance that you're going to be late.
So this example that you gave about the training and that tool within the QMS, that's really, am I being too parsing to say that that's more of a machine learning thing rather than something you would call AI?
Yeah,
Okay.
you grasp this very, very clearly. And people who were doing machine learning for long enough, they know that this is so-called tabular models, right? Not based on the processing the natural language, not based on understanding the image with the computer vision. It is based on the representation of the knowledge in a tabular format where it's all readable, right? And you're making these predictions from quite explainable variables, easy to grasp, easy to explain.
Okay, all right, excellent. Let's take that a step further. This morning there was some discussion about, you could hear it in the audience when the speaker said, we like to stay ahead or anticipate what the FDA is doing.
Yeah,
For obvious reasons.
for obvious reasons.
We'd like to anticipate, I believe the phrase was, what's on the mind of the FDA. Can you discuss that and how it relates to what you're doing?
Yeah, and it's nice that you captured that sentiment because for somebody who's presenting on stage, I couldn't hear very well. I'm really glad that it resonated because it was an experimental kind of initiative. How much external data can help the customer? How much this awareness about what's in FDA's mind can help, right? Not your data. And that's cool to hear that it's actually very much expected.
I'm sorry, it's called what?
That it's much expected.
Oh, okay.
Yeah, because FDA's data is publicly available. They have to provide it. And in a sense, any machine learning scientist can pull that data and analyze it for the purposes that we analyzed. What's on FDA's mind? It's just that data miner or machine learner won't have a context how painful it is, how much needed it is, and for whom, right? So what we did, we took that corpus. It's a quite sizable corpus. of long descriptions and short descriptions, something that people actually don't want to see, but they need to see.
Right.
Because 483 is like a curse word, right? If you've been cited in 483, it's bad.
Right, right.
If you are anyhow close to that, if there are not citations yet, but only observations, it's still already bad. So how to avoid it, right? If you know what the enemy is, you can probably build a line of defense. So with that in mind, what we did, we took a machine learning model that is learning a context. So it's very different type of model that we discussed before. It's not tabular. It is using the natural language processing techniques, cleaning the data, parsing the data, and based on a very, very large corpus of data, not necessarily FDA, not necessarily regulated, related at all, right? Just based on a normal reasoning facts from human life. There is a pre-trained model that is allowing you to translate any sentence into, let's call it a vector, right? A vector of some sort. A space where you can measure if this sentence is similar to that sentence and how much this sentence is very far from that sentence. In other words, you are measuring how much similar things are, right? So if you do it over a huge corpus, you can actually start seeing a nice conglomerations of, oh, those dots or sentences are close to each other. And then those are the densities of dots which are very, very close to each other. Between them, there's a huge distance, so they're far from each other. Let's look at those densities. You can translate them back and understand that, oh, those are all about gloves. And machine is smart enough to understand that the gloves only can be used in a context of sterilization, right? It's amazing to realize that there is no single word of sterilization in a sentence. It's all talking about
other data
that
points.
model is learning the context.
Right.
And because of that, there is an impression that it knows, it understands the meaning, right? So all the technical details apart, what is it needed for a customer is to, oh, I want to look at the act number such and such. Can I see what was in FDA's mind for my specific industry? Oh, it's about this, 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 and this. What was for CFR such and such, right? CFR is our bread and butter. Oh, I can look at the paragraph such and such in CFR and see what were the citations there. And it's not a chaos anymore for me. It's not a huge database that is probably absolutely not interesting. I can find for my specific program area, for my specific act number, what are the main things that for the last, say for instance, year led to citation.
So if I can super oversimplify it, would one example be such that you're seeing this data, you're seeing it presented to you, and what your conclusion is, there is an increasing trend of probability that our workers will be cited for not wearing properly changed gloves.
That or there was
during
a visual
some process, and there's a 200% greater chance we'll get a citation for it.
Yes, yes.
So what were you going to say just now?
I was about to say that it's not only that not wearing the gloves, but a very subtle things like, and FDA as observers, they're very, very observant. I mean, that's what they're paid for, right? It is somebody was leaning towards with their bare hand.
Okay.
Right? No word of a glove. There is no sterilization. Somebody was leaning, but that environment where that person is observed is not supposed to be leaned toward with a bare hand.
They're implying that, because really it's about sterilization, not about gloves.
Yes. That
Fascinating.
is so powerful.
Absolutely fascinating. Earlier we were talking about, just to shift topics a bit, about the way it struck me is that machine learning can help humans, in the way I heard you was, enjoy their job more by doing certain things that allow the humans to focus more on the creativity and so on. Can you explain that a little bit further for me?
When artificial intelligence hype has started, there was a camp of people of kind of seeding this awareness. Oh, it's a job security thing. And for me, it was like really, really strange. It's probably not enough media coverage, that artificial intelligence is not about replacing people,
Oh,
not
it was,
at all.
It was the job security thing about
Right,
AI and
right,
machine learning is
right,
going to
right,
take the humans'
right,
jobs away.
right.
Okay.
And it's absolutely not about that. It is, there are so many examples where data, mundane data, can be cranked and analyzed by machines so much faster that everything that is above that is your job now. You can create, you can co-create, you can think, you can brainstorm, initiate, instead of being buried in a pile of Excel files.
In other words, it frees you up to use your
Absolutely.
limited time
Yes.
to do the things that
Yes.
you've wanted to do, but you
Right,
never had time
right,
to do.
Right, or finding new things to do.
Right.
Yes.
Absolutely fascinating. Last question. So, the Human Genome Project is something we studied quite a bit. 15-year project, started a couple decades ago, and at about the 7.5-year mark, halfway through, they had decoded barely 1% of the genome. And all the skeptics said, and they really came out of the woodwork, said this, we knew this wouldn't work, this is going to take forever, you're way ahead, it's going to take 100 years before we get it done. By the time the project was over, they had succeeded, because the power of the exponentials literally took over. They had made tremendous progress going from 0 to 1%. But people think that that's nothing because 1% is, they were poo-pooing it. But when you go from 1% to 100%, that's only 7 doubles.
Right.
1, 2, 4, 8, 16.
Right.
How do you think that is going to relate to AI, machine learning in a practical way?
I would love
that
to.
same mathematical concept.
I would love to that somebody will actually go and implement this Gedanken thought experiment that you're proposing, right? How much faster the genome project could have been done if AI would be like full player, right? Because it started way before AI. AlphaGo and AlphaFold. It can find faster all conformations of molecules, right? Machine can go, because it can go through mundane permutations of all possible ways how the molecules, protein molecules are conforming. Isn't that the fantastic thing? That you can permute and find it just like playing, only playing. There is nothing there about reasoning, making things like a human mind will do. No, it's just going through the examples and patterns faster. Faster, more robust, scalable, errorless.
And do you think machine learning in itself, forget about the application of it, will follow that same exponential curve of power?
I think so, and especially for regulatory space, and I explain why. As a machine learner, I thought that I kind of touched almost every application, right? Financial, healthcare. I even did brain recording. Customer, consumer, electronic consumer. It was a surprise for me to realize that there is a niche of knowledge, data, information regarding the compliancy and quality, which is actually like made for AI and ML because it is so regulated. So it's not microscopic and it's not macroscopic. It's not like economic level. It's mesoscopic. It's in between. It's very, very regulated, so it's not infinite. You can find a solution because machine learning eventually finding hyper-parameterized landscape of a solution, right? You want to find where is X, where is Y, where is X, where is Y. And sometimes the landscape could be very, very convoluted. And machine learning is supposedly have to find the margin between X and Y very, very widely for you. So this mesoscopic niche and pocket gives a hope that solution will be found. It's not infinite, so you'll find it. It's just how you will find this convoluted kind of landscape. I think in a regulatory space, machine learning, especially with the tabulated models, is fair game, and it will bring a very, very spectacular results. I don't want to brag, but one of the reasons why the model about training management is getting fast, because we're witnessing a very good accuracy. It's a KPI of machine learning. very high accuracy, and it can generalize well. The way we test for the generalization, usually in machine learning, you're trying to withhold the set. The best one is in the future, right? You train on the data that past, and then you train and you test in the future, the data that never been seen by machine during the training.
Yeah.
And we can generalize with the same accuracy. And even more, we test it on a data from a different locale. So we trained on US, and we tested on UK. In other words, patterns of a human procrastinations are universal.
Are universal.
Right?
I was going to ask, are the Brits more...
Maybe they're going to be very different from Japanese or German.
Right.
But and decisions about how much somebody is a procrastinator because of that can be generalized. So that result is so inspiring that it gives me a huge hope.
Fantastic. Excellent example. Thank you. Thank you. Viktoria Rojkova, Vice President, Artificial Intelligence, Machine Learning, and Data Science. Thank you very much.